Hi, folks. Let's take a moment to look at the rest of the 3.10 inverse trig things. In all of our classes, we left off with a couple problems. One, finding a derivative for arc secant. It's in the table, but there's a way to do it. And the general way to do that is to write the equivalent equation x equals secant y and differentiate both sides by x. And when you do, you get 1 equals secant goes to secant y tangent y derivative of y by x. And so derivative of y by x is 1 over secant y. I'm going to write secant y. Well, let's do that. Secant y tangent y. Then let's rewrite secant y as 1 over cosine y and tangent as sine y over cosine y. And once we do that, now we're going to be able to write dy dx, the derivative now is going to be 1 over sine y over cosine squared y, and we end up with cosine squared y over sine y. Now we want to write the derivative back in terms of x, and to do that, you need to look up here at x equals secant y. The x on the left, that's an x over 1. Secant has side ratios over right triangle, hypotenuse over opposite, set, hypotenuse over adjacent. Because cosine is adjacent over hypotenuse. Secant is the reciprocal. So hypotenuse over adjacent. That tells us on a right triangle, we have x equals secant y. It informs a right triangle with angle y. Adjacent is x. No, hypotenuse is x. Adjacent is 1. That makes the other side root of, I think, x squared minus 1. We should probably work that out. Here, let's work on the Pythagorean theorem. So 1 squared plus the opposite side squared. Opposite side squared is equal to x squared for the hypotenuse squared. Opposite, let's see, we had it right. Opposite's going to be root x squared minus 1. So here's our triangle set up with the ratios, and we need to put in cosine squared y over sine y and see what happens. Let's see. So sine y is opposite over hypotenuse. Opposite is root x squared minus 1 over x. Cosine squared is adjacent over hypotenuse and it's squared. Adjacent over hypotenuse is 1 over x. So we end up with 1 over x squared, and then times the reciprocal of the denominator, root x squared minus 1, and we get 1 over x root x squared minus 1. And we definitely have more going on there because we should get absolute value over here. So when we take the root, we should get a plus or minus in there, and that informs this plus or minus. And for more info on that, then when we take the plus and minus going on, it's going to inform our x squared to be giving us an absolute value of x. For more on the plus and minus, let's tell you, for more on plus or minus, read on page 220 to 221. It'll explain that in a little more detail. All right, let's pause for a minute and then we'll go find another problem. We're back. Let's find the equation of the tangent line to function g equals arc secant 2x at 1 minus pi thirds. 1 minus pi thirds tells us we already have the point. So we have y minus the function value at location 1. We're going to need y prime, g prime at 1 and times x minus 1. So what's left to do is to figure out the derivative at 1. Our derivative, g prime arc secant, is 1 over absolute value of the thing. Thing is 2x, that's our inner function. So 1 over absolute 2x, going to be 2x squared minus 1, and then times the derivative of our inner function, times 2. Then, let's see, we end up with 2 over, the absolute of 2x is going to be 2 absolute x root 4x squared minus 1. And we want to evaluate this at 1, 1, and 1. So the 2's cancel. They are going to reduce to 1. When we plug in a 1, this one is going to go here for that x and that x there. So when we're done, we end up with 1 over absolute 1 is just 1. I'm not going to write that. And then we end up with root of 4 minus 1. So we get 1 over root 3. 1 over root 3. That is the slope of our tangent line. Let's see. So x minus 1, pi thirds minus y. There's the equation of our tangent line. And I think there might have been one more in here. Yeah. Okay. Arc cosine, cosine, 3 pi. So arc cosine and cosine undo each other and you just get back 3 pi. However, 3 pi is not 3 pi, but 3 pi is not in our interval for arc cosine being 0 to not 2 pi, but pi. So if we had a unit circle, let's take a unit circle. Let's pretend that looks like a circle-ish. Let's make that a little bigger. Okay, so here is our unit circle. Here's angle 0, pi halves, and pi. 3 pi is over there also. If we started at 0 and then went around 1 pi and then kept going on the way around, that's 2 pi, and then kept going all the way around at 3 pi. 3 pi is over here at pi, also 3 pi, but pi is in our interval. So we're not going to report 3 pi, we're going to report pi for our angle. Then, yeah, then nothing, then we're done. I guess another way to have done that would be to evaluate cosine of 3 pi. So if we had arc cosine of 3 pi, this is arc cosine. 3 pi is -1. And then again, arc cosine is asking you for which angle in the unit circle is there an x value of -1. And there's only one angle on the unit circle, or one location, I guess, and that location's over here at pi. So you could write 1 pi, 3 pi, 5 pi, 7 pi, any odd multiple of pi for odd positive integers, but we only want pi. So equals pi, again, because of our interval 0 to pi. All right, y'all take care and stay in touch.